All right, here we go. So today we're going to be learning section 1.3, properties of real numbers. So the properties, for some reason, just like always get mixed up. A lot of the time students forget the difference between the commutative property, associative property, identity property. So hopefully after today, we can clear up any confusion that you might have had in the past, and we can commit these to memory because it is very important that you do understand the difference between these properties and the way that they work, because math is basically built on these properties. So the first property is the commutative property. So you might have brothers, sisters, you might have cousins, friends, family members that go to college and they don't actually live there. Like when I went to Millersville, I lived there, so I was not considered a commuter. When you are a commuter, you don't live at the school because you are constantly going back and forth between home and school. So kind of like when you are just going to high school, you guys don't live here, so you guys are considered commuters because you come back and forth to school each day. The commutative property takes numbers and moves them back and forth. So kind of like when you're a commuter, you start here, you go there, and then come back. That's what happens with the commutative property. So in math, they always like to give you definitions, like all these fancy definitions with all of the variables and whatnot. We're just going to kind of keep it simple. So I'm using variables first, so you can see that's the same thing with variables as it is with numbers. The commutative property says any number A plus any number B is the same thing as if you switch the order and you put B first. The commutative property works for addition and multiplication. So here's an example of addition. Multiplication, same exact concept. If you have A times B, it's the same thing as switching the order and it B times A. Okay, so that's with variables. With numbers, if we just pick any nice easy numbers, with addition, 1 plus 2 is equal to 3, and that's the same thing as switching the order and it being 2 plus 1. Right, we still get 3. So the commutative property takes numbers and actually moves them. So it's kind of like they switch places. It works for multiplication as well. I'm going to use not 1 anymore, I'm going to use 2 and 3. 2 times 3 is equal to 6. That's the same thing as 3 times 2. Okay, so you switch the order and you get the same exact thing. That's the commutative property. The associative property is different than the commutative property. The commutative property changes the order of the numbers. The associative property, the numbers stay in the same exact order, but what happens is the grouping changes. So I like to explain this and connect this to real life. Like you guys probably have different groups of friends. Like I know when I was in high school, I had friends from like my club sports, right? So I have these friends from club sports. I have these friends from school. And if I had my birthday party or something, I would invite my friends from my different parts of life, and then we would all be at one same spot for my birthday party. So I can associate with different people. Kind of like if you're at lunch, and if one day you're sitting with this group, and the next day you're sitting with this group. All together, the same people are in that room. However, you might be associating with different people. That's what the associative property does as well. It takes numbers and groups them. The numbers are still all there, but they're just grouped differently. So an example with variables would be like if we group together A and B in grouping symbols like parentheses, and then we have a number on the outside like plus C, that's the same exact thing as if we group the numbers differently, and instead of grouping A and B together, we group B and C together. So what happens here is the order does not change. Notice, in the associative property, it's A, then B, then C. A, then B, then C. But what does happen is the grouping changes. So they grouped A and B together first, C was on the outside, and then it changed, A was on the outside, and B and C were grouped together. Using numbers, if we had like 1 plus 2 plus 3, that's the same thing as 1 plus 2 plus 3. Now, I said that out loud quickly because I wanted you to see the order of the numbers does not change when you have the associative property. 1, then 2, then 3. 1, then 2, then 3. The commutative property, numbers actually switch places, but the associative property, they stay the same. What changes in the associative property is the way that numbers are grouped, which will change the way you would solve these problems using the order of operations. Like the one on the left, I would do 1 plus 2 first and get 3, and 3 plus 3 is 6. The one on the right, I would do 2 plus 3 first, get 5, and 1 plus 5 is 6. So it's a different process, but the same answer. All right, this works for multiplication as well. So with multiplication, we could take like a times b in parentheses and then multiply it by c. That's the same thing as a times b times c. Notice the a, the b, and the c stay in the same exact place. What changes is the grouping. With numbers, if I did 1 times 2 times 3, that's the same thing as 1 times 2 times 3. I would solve these problems a little bit differently. I would do 1 times 2 first and get 2. 2 times 3 is 6 on the left. And on the right, I would do 2 times 3 first and get 6, and 1 times 6 is 6. So you get the same answer, the process is different. Okay, so those are the ones that get mixed up all the time. And then sometimes the identities and inverse properties get a little bit confusing. The identity property for addition means you can take any number and you can add 0 to it, and then the number stays identically the same. So the identity property is like what number can you add to a number and keep it the same. That's the identity property of addition. For multiplication, it would be take any number and multiply it by 1, and the number stays exactly the same. So the identity of addition, you're thinking of 0. The identity for multiplication, you're thinking about 1. All right, the additive inverse property. So inverses basically are trying to like undo something. So like if you're trying to inverse something, you're taking it and undoing it. So the additive inverse means you take a number like a, and what number can you add to a to make it 0? So in order for us to take a number and add a number to it to make it equal to 0, you have to take the opposite of that number. That means like a plus negative a. In number form, this could be like 3 plus negative 3. Basically, for the additive inverse property, you're just taking opposite numbers, and those are inverses of each other, like 2 and negative 2. They're inverses because they add to 0. Negative 1 and 1, they're inverses, they add to 0. For multiplication, the inverse property you're not looking to try and get 0 as your answer, you're trying to get your answer to be 1. So this is a little bit different. So if you have a number a, and you're multiplying it by another number, and you want the answer to be 1, you're looking to multiply it by its reciprocal. Okay, so the reciprocals mean basically the number flipped upside down. Right now there's an invisible 1 underneath of the a. It's like a over 1. We never write that if we don't have to. So the inverse of a, if I flip it upside down, is 1 over a. All right, looking at number forms of these so you can see how this works. The additive inverse property in a number example could be like 3 plus negative 3 equals 0. Those are opposites. They're called additive inverses. And for multiplication, if we do like 2 times 1/2, that would equal 1. And that's because these are inverses, because 2 times 1 over 2 equals 1. That would be considered the multiplication inverse property. Okay, so the rest of the page is asking us to look at these properties and identify which one they are. Wait, did I skip one? Oh, wait, sorry. The distributive property. So the distributive property is the last property before we do examples. And the distributive property is the first property that requires you to actually do some math. So the distributive property is going to be asking you to simplify something. So the distributive property usually will have a number on the outside. So the number, I'll use like a nice easy number like 3. And then in parentheses, you're going to have some sort of algebraic expression. So the algebraic expression I created was 2x plus 1. The distributive property is a way for us to simplify that thing that I just wrote there, 3 times 2x plus 1. If I said solve this using the order of operations, or simplify, I should say, using the order of operations, you'd be stuck here at parentheses because you can't add 2x and 1 together because they're not like terms. So to simplify this and get rid of the parentheses, you have to use the distributive property, which says multiply everything on the inside of the parentheses by the number on the outside. So we would multiply 3 times 2x and 3, I'll just do this on the side, 3 times 2x. You can multiply numbers that aren't like terms like this. This still works. You just multiply the 3 times the 2 and get 6, and then add the x. So 3 times 2x is 6x, and then you would multiply 3 times 1, and that's just 3. You hold it together with the plus sign, and then that would be considered your simplified answer. So the distributive property takes numbers on the outside if we use variables, like a number a, and then numbers on the inside, like b plus c, and it distributes, it takes that a and gives it to the b and the c. So it becomes a times b plus a times c. Okay, now we're ready for some examples. So looking at these examples here, in example 1, we are trying to identify what's happening in number 1. So we see this is 4 parentheses a plus 3. So I see on the left-hand side and the right-hand side look different. And then it becomes 4a plus 4 times 3. So what they're doing there in that property is the distributive property, because I can see that they're distributing the 4 to everything on the inside of those parentheses. All right, so letter A, the first example, would be the distributive property. Okay, for the second one, B. This is negative 3 plus 2 plus b equals negative 3 plus 2 plus b. Notice that everything I said was in the same order. So that sometimes it's really helpful to say these out loud or just like in your head and see, are they in the same order? If so, it's not the commutative property. What changed here in B is that the numbers were grouped differently. In the first one, 2 and b were grouped together. In the second part, negative 3 and 2 were grouped together. So this would be considered the associative property. And this is the associative property of addition. In C, we are multiplying 6 times 1/6, and that equals 1. Well, looking at the different examples I have here, that would be considered the multiplication inverse property. Multiplicative inverse. And then the last one, we have b plus 8 plus 0 equals b plus 8. So I can see that we are taking b plus 8 and adding 0 to it, and it stays identically the same. That would be the identity property of addition. Okay, so when you're labeling these properties, the words are pretty long for all of them, so if you wanted to abbreviate, that's fine. As long as you understand your own abbreviation, that works for me. And then the last couple of properties we have before we are done with the properties for today is we have the addition property of equality and the multiplication property of equality. All right, so that sounds super fancy. But basically, all that means is whatever you do to one side, you do to the other for addition. And then for multiplication, same thing. So, if we have two numbers that equal each other, like A equals B, let's say. If A and B are equal to each other, and we take these and we add a number C to it, then they're still going to be equal. Okay, so if A is equal to B, then it's true that A plus C is equal to B plus C. All right, and then for multiplication, same kind of idea. If A is equal to B, then A times C will equal B times C. All right, that's just meaning that if you take a number and you add it to one side, you have to then add it also to the other side, and it will stay the same. All right, and the last thing that they want us to do on this page is solve this equation for x, but like we're not actually there yet to solving equations, so this is just kind of a, I guess, refresher, but this has nothing to do with the properties. So I'm going to still do it just because I'm sure you guys are able to do this. If we were solving this example, this equation for x, 3x plus 4 equals 10, showing our work, we understand that when we are solving equations, we have to undo the addition or subtraction first, and then multiplication or division. So the first thing I would do is undo this plus 4 by subtracting 4 from both sides. These 4's cancel out. I'm left with 3x on the left-hand side, and 10 minus 4 is 6. I have 3 times x is equal to 6. I'm trying to solve what x is equal to. Well, to undo what's happening here, this is multiplication, I would divide. So I would divide everything by 3, and I'm going to get x is equal to 2. But that problem had nothing to do with what we just went over, so don't get confused by that. All right.